Okay, we're live. There's 18 questions.
Hopefully we can do it all in Excel.
Oh my gosh, yes. Isn't that just the nicest little thing?
Yes.
Okay, you ready for number 3?
Yep.
The symbol for the true population portion is which of the following?
I thought it was just P, right?
Normal P.
Yeah, that's
Yep.
what I
Yep.
do.
Ooh, what did it do?
Okay, so for the next 2 questions, suppose N equals 100, 0.25, and P hat is 0.1. Are the requirements for constructing a confidence interval satisfied with these numbers? Isn't it the same thing for the hypothesis test?
No, this one is N.
P, oh, okay, I gotta stop saying that. P with the little hat is greater than or equal to 10, and N times 1 minus P with the little hat is greater than or equal to 10. So the first one is met, and the second one is met. It's true.
But do we use the same? We use the same formula to find out if they're good for conducting a hypothesis test as well, correct? If conditions are satisfied. Yep. So it's the same formula for the next question too.
So it's true as well.
Because they both equal 10, more than 10.
Right.
All right.
Okay, question 6. A study of first-degree murder trials was conducted in another state. This random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found not guilty. Find P hat, the point estimate of the proportion of first-degree murder defendants who are found guilty in this state.
So wouldn't this one just be 60 divided by 45?
45 divided by 60, but
60.
yeah.
45 divided by 60. Yeah, sorry.
So I got 0.75. Does that sound right?
Yep.
0.75?
But it 0.750 because it needs to be rounded to 3 decimals.
Right.
Okay, number 7. Create a 95% confidence interval for the true proportion of the first-degree murder trials in this state. There, the verdict is guilty. Input your answers for the margin of error, lower bound and upper bound. So determine margin of error for this 95 confidence interval around the 3 decimals. Okay.
I got an answer.
Okay.
I have one too.
I wish the Excel spreadsheet would tell you the margin of error.
Yeah.
Yes.
But I guess
Okay.
you can do 0.86 minus 0.64 and divide by 2.
I don't think it works.
I don't think it works either.
But maybe you could try it. our sample size?
What was the sample size again? 40?
60.
45.
60, sorry.
Oh, 60.
So
But are we doing
we're
it?
rounding
Are
to
we
3
doing it
decimal
on
places.
45 though?
Are we doing it on what?
45. Like, are we using 45?
We have to use the p hat, 0.75.
Okay.
We
Okay.
have to make it into the percent. But
What did you
So-
guys get?
I'm still working it.
So mine might be wrong, but I got 0.110. That's rounded.
I got 0.110 rounded too.
Okay, I got that too. I didn't do it with the formula though.
You did not do it with the formula?
No, I found the confidence interval, and then I just subtracted the big one. I subtracted the smaller one from the big one and divided by 2, and I got 0.11.
Okay, so will you tell me, I'm looking at the spreadsheet right now in Excel. So we put the input in, right? The 45 in the X box and the 60 in the N box, and the confidence level is 95. But what do I put in
So down the bottom
no-
of one proportion z-test, it will give you your confidence interval.
what do I do here? And it's this null hypothesis has a number in it. What do I put there? Nothing? What do you have there?
I have 0.70. Does it say what the null hypothesis is?
No, that's why that is confusing because whatever's in there seems to affect it. I don't know. So I just didn't know. So I haven't.
Yeah, I probably didn't do it the right way, but somehow I got the same answer. So
No, I.
it doesn't affect the
All right.
confidence interval.
It shouldn't. It shouldn't.
Well, it doesn't. I don't know if it shouldn't.
This is one thing that I'm struggling with is because I want to use that. I just don't know how to. Average times.
The only thing that I don't know. I probably shouldn't have done it that way, but I didn't have the formula with me right now. So
Okay, can I ask you what you guys got again? Because I'm not getting what you guys are getting.
I got
The
0.1.
point.
Say it again?
0.110. 0.110.
No.
Let me go back to the. Does someone want to read out the formula to me? Because I don't have it on hand.
Okay, it's
The
It's
margin
the-
of error formula, right?
Yeah.
M equals Z score, square root of P times 1 minus P all over N.
Okay. So P is
0.75, right?
yeah.
what's P hat?
Well, yeah, that's what I meant, but it's still the same thing.
0.75.
Then what's P?
We don't have one here. We just have a point estimate for P, which is the P hat.
So we have to use that.
Wow. 2.75 times 1
Okay.
minus.
So yeah, my confidence intervals that I just formulated with the formula do match the ones in the software. Weird.
Divided by 60 times Z score. What's the Z score?
1.96.
Because
Right?
we're dealing with, yep.
Oh, crap, I didn't take the square root. Okay, square root this answer.
Oh my goodness. I apologize, guys. I'm dyslexic.
Oh, did you just, okay. I do that all the time. I transpose. But I did use the formula to find the upper and lower bound, and they do match the numbers that the software computed. So that's totally cool.
Okay, doing it the way the formula wants me to do it, I didn't get that answer.
Did you get 0.110?
No. But doing it the way Excel has me doing it, I got the right answer. I'm gonna redo this real quick. Wait, 75. Divided by 60. Okay. And then take the square root of that. And then multiply that times 1.9. Okay, now I did.
Yep.
So now we need to find the upper bound and the lower bound of the confidence level. And I used the software and I used the formula, and it came out the same.
0.64 is the lower bound,
That's what I got.
Yep.
and then 0.86 for the upper.
Yep.
No.
That's,
Did somebody say no?
I said yep, sorry.
Okay.
Yes.
And just add a 0 on the end. Okay, number 10. If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? And this one, I think, is a decrease.
Yeah.
Yeah, I agree.
Because as the sample size increases, the confidence interval decreases because it narrows it down.
I would agree.
To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 0.5. What is the smallest N can be, and both requirements still be met?
So is this the one where we just plug it in? Like plug the values in on both sides?
No, that's the one where it says N equals Z-score over 2, margin of error, and then square it. Because we're trying to,
Go ahead.
I was going to say, because it was the last formula, I think, that says if no prior estimate for P is available, we can use this formula to compute our sample size.
Okay.
Are we still using the information?
I don't know.
Let me see.
I don't think so. I think we're just looking for a.
Right, I think so too. And if that's the case, yeah, it doesn't say whether we're supposed. I just went back up and it just says input your answers for the margin of error, lower bound and upper bound. I wonder if we're supposed to use the margin of error though.
I don't think so, because all we have to, don't we have to just put them in the NP 10 or we put the P in and then we solve for N, right?
Yeah, see, that's what I thought.
Okay, I got an answer, but I don't know if that's right either.
Let's try it.
So I got 20, but
I got 22, but I'm gonna check it with the other one. I think it's 20, but let's double check.
I got 22, but I didn't do it the way you guys did it.
Yeah, I think it's 20. I got 20.
that's what I got too.
Okay. I got the same thing.
I put them in both of the formulas to meet the requirements, and it came out to 20 both times. So Michael has a special way to get it done.
I just put it in Excel and get that.
You mean you just put those things in there?
Because it says that P is 1/2, so it has to be 1/2 of the sample size. So I just put in, I started at 1 being P and N being 2, and I just kept on increasing the halves till I got the requirements. Of course, in a really big number, that wouldn't be good to do, but.
Oh. Okay. So now we have to do another one?
Yep. Number
Yes,
12.
question 12.
To conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose P equals 1/10. So what is the smallest N can be and both requirements are still met?
100.
Is that like the same one though? That's like the same deal, right?
Hypothesis, though.
Hmm.
It's still the same thing.
But we still do the same thing to see if it.
Yeah,
Yeah, we still do the same
Yeah.
thing.
and I agree with Marie. I think it's 100.
Yeah, I don't see any other way it couldn't be.
Yeah, I see 100 as well.
Because if you do 1 in 10, it doesn't meet it. And then to have another 1 in 10 size, you have to go 1 in 100.
Mhm.
Okay.
Man,
Well, at least for this one, we'll be able to use all the information for the last 6 questions.
Oh, good.
So it's
Yeah.
everybody ready?
Yes.
For the water quality study in the reading, about 60% of the macroinvertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using significance level alpha as 0.05 with the following hypotheses: that the null hypothesis P equals 0.6, and the alternative hypothesis P is less than 0.6. They collect new data, and this time N equals 80 and X equals 38. Indicate good health. Question 13. The conditions for conducting a hypothesis test are satisfied.
okay.
They are to me.
True.
Yeah, true.
The type of test is less than, right?
This one says less than 0.6. So that means P is 0.6, but our P hat is actually 38 divided by 80, which is 0.47, 0.745, 0.75, 0.475. Sorry, let me try that again.
So,
0.475.
Whitney, did you stick it in your in the Excel spreadsheet?
I did not.
Okay, never mind then.
But I guess we should.
Well, my only question is, so would null hypothesis be 0.6?
Yeah, null hypothesis would be the 0.6.
And then the type of test would be less than?
Yeah, because that's what we're testing for. And then you'd put your X value, which they said was 38. And then you'd put your sample size, which is 80. And then you put
okay.
it. And so it says that our test is met. But then what were we just computing? Forget. We were just figuring something out, but I don't remember what it was. If it was. Okay. And so now we're on P hat?
No, now we're on test statistics.
Oh, we already did P hat? Sorry.
I did it.
0.475. And did it totally figure it out? And then let me look.
As far as I'm concerned, it figured out what the test statistic was.
Wait. So did you get 0.5 for a test statistic? Because when I do the calculation, it says .475. Does it say to round?
That's P hat.
0.475?
Yeah.
Okay, but in the software it says 0.5.
No, it doesn't.
Okay, mine does. What am I doing wrong? Because our regular P is 0.6 and we want less than. Huh. Okay.
Let me see how that would change.
My P hat says 0.5 with a sample size of 80. Did I write it down right?
And your X is 38.
And yours says 0.475?
Yeah.
No, yours says 0.5. Mine says 0.5. Okay. Blast. Will that affect my test statistic? Because what does your test statistic say? 'Cause it says,
It does affect it.
mine says negative 1.826.
I got negative 2.282.
Okay, I got negative 2.2822.
2,
Yeah.
2.282.
Negative.
Negative, negative.
Is that what you got,
Yeah.
Marie?
I made a mistake. I got 2.282, but I didn't get negative. But I'm doing it by hand.
You're doing it by hand.
Hmm.
That just
And
means you messed up one of them.
Yeah, that's
Symbols.
why I said it was just me.
Okay, and then p-value, I got 0.011.
I got that too.
Okay.
This is P. This is P value. Because we don't have enough P's in the class. We have P hat, we have P, and now we have P value.
Okay, so if we have a p-value of 0.01, that is
0.011.
Less than 0.5, our sigma, our alpha. So if the p is low,
Let him go.
reject the null.
Yep.
So
And
we
then
As we rejected,
number
there's
18, since we rejected it, there is sufficient evidence to conclude that water quality in the area has decreased, right?
Correct.
Okay, I will submit mine and then we'll see. Oh, I got 100.
Yay! 2 in a row. Woohoo!
I know.
what did you guys put for, 14? 14 is our
Number
0.47.
Correct. Right, Whitney.
Yes.
Sorry, I tried to write everything down so that I can. Anyway, okay, excellent.
Okay, so how do we submit the? I missed one.
Oh,
Which one did I miss? Oh, I messed up on the upper bound. That's not a big deal.
the upper bound,
Yeah,
0.860.
yeah. I wrote 0.840. Okay, so how do we submit the design? Does only one of us submit the design, or
No.
do we?
We each have to do it.
Right. So I'll make the corrections and then I'll send it to you guys to submit.
But where do we submit it?
At the design study, there's if you go to the design study, that's in this week. It says design study directions. Click on it.
Yeah.
And then it'll give you it has within the directions like a link to the actual design study.
And click upload.
Correct.
Oh, that's weird how they do that.
Will you send it to us, Marie, when it's all done?
I will. I'll take care of it.
So
tonight.
no problem. It's due Saturday, right?
Yes.
Yep.
Okay.
Good job, guys.
Yay.
Thank you so much for all your help and patience.
Be sure to copy the link and post it on the group page.
Yep, I sure will.
All right.
Thank you.
Night, guys. Bye.
See you later.
Bye.